Dear student, today we will see chapter number 1, Similarity. In this chapter, we are going to learn about property of three paralines and their transversals. And even we are going to solve some questions based on property of three paralines and their transversals. If you have not subscribed my channel, please subscribe it today itself. Let's start. Property of three paralines and their transversals. Let's see the statement of this theorem. The ratio of the intercepts made on a transversal by three paralines is equal to the ratio of the corresponding intercept made on any other transversal by the same parallel lines. In this theorem, you can see there are three paralines and there are two transversal for those three parallel lines. So here we have a figure. You can see that in this figure, line L, line M and line N are parallel to each other, and T1, line T1 and line T2 are the two transversals of those three parallel lines. So what is given here? Line L parallel line M parallel line N, and you can see in this figure transversal T1 intersect line L, M and N at point A, B and C respectively, and transversal T2 intersect line L, M and N at points P, Q and R respectively. Look at in this figure what I have to prove. The ratio of intercept formed on transversal T1 is equal to the ratio of intercept formed on transversal T2. So first we will try to understand what is intercept. So what is the intercept? Intercept is nothing, it is a segment which is formed on a transversal by two parallel lines. Okay, so look at in this figure here, seg AB is the intercept formed on transversal T1 by two parallel lines L and M, right? Look at in this figure, seg BC is the another intercept formed on transversal T1 by another two parallel lines M and N. Similarly, seg PQ and seg QR are the intercept formed on transversal T2. So what I have to prove here, the ratio of intercept formed on one transversal is equal to the ratio of intercept formed on one transversal. That is AB upon BC equals to PQ upon QR. To prove AB upon BC equals to PQ upon QR, we are going to take the help of basic proportionality theorem. And you all know this theorem is applicable in a triangle. So here we required a triangle to apply basic proportionality theorem. So here we required construction. What we will do here, we will draw seg PC and let it intersect line M at point D. And you can see that because of seg PC, here we got two triangle APC and triangle PCR. And in both the triangles, we are going to use basic proportionality theorem. So let's see that. We will take first triangle ACP. Look at in this figure. Here I'm going to take triangle ACP. And you can see that in this triangle, seg BD is parallel to seg AP. Do you know why seg BD parallel to seg AP? Since line L and line M are parallel to each other. So I can use here basic proportionality theorem. What we will get? We will get here AB upon BC equals to PD upon DC. We will consider this step as equation number 1. Now we will take the other triangle. Look at in this figure. We will take triangle CPR, and you can see that in this triangle CPR, seg DQ parallel seg CR. Seg DQ parallel seg CR, since line M and N are parallel to each other. So here we will apply basic proportionality theorem. We will get PD upon DC equals to PQ upon QR. We will consider this as step number 2. Equation number 2. Now look at equation 1 and equation 2. Can you see equation 1 and equation 2? You can see that both the equation have one common ratio, that is PD upon DC. Therefore, you can say that all three ratios are equal, that is AB upon BC equals to PD upon DC equals to PQ upon QR. Okay, this step we got by comparing equation 1 and 2. So I can say that AB upon BC equals to PQ upon QR. So here I have proved it. The ratio of intercept formed on transversal T1 is equals to ratio of intercept formed on transversal T2 by 3 parallels L, M and N. This is called as property of 3 parallels and their transversals. Now we will see some questions based on property of 3 parallels and their transversals. So here we have first question. In this figure, here AB parallel CD parallel FE. Then find X and AE. You can see that in this figure there are 3 parallel lines. So we are going to use here property of 3 parallels and their transversal. What is this property? This property says that the ratio of intercept formed on one transversal is equals to the ratio of intercept formed on other transversal. So here AB parallel to CD parallel to FE, right? It's a given. So AC upon CE equals to BD upon DF according to property of 3 parallels and their transversals, right? You can see AC and CE. Look at in this figure here, AC and CE are the intercept formed on one transversal, and BD and DF are the intercept formed on other transversals. And the ratio of the intercept formed on one transversal will be equal to the ratio of intercept formed on other transversal. Now we will substitute the value. We will get here 12 upon x equals to 8 upon 4. So x equals to 12 into 4 upon 8. We will simplify this. We will get x equals to 6. Look at in this figure here, x is the length of segment CE. Therefore CE equals to 6. Now we have to find out here AE. Look at in this figure. Here seg AE is sum of seg AC and seg CE. So I can say that AE equals to AC plus CE. Therefore AE equals to 12 plus 6. Therefore AE equals to 18. Here we have next question based on property of 3 parallels and their transversals. It is given that in this figure AB parallel CD parallel EF, and if AC is 5.4, CE equals to 9, BD equals to 7.5, find DF. So we will apply here properties of 3 parallels and their transversals. So we'll start with the first step here, AB parallel CD parallel EF, right? These 3 lines are parallel. How we came to know, it's a given. So we will use here property of 3 parallels and their transversal. What it says, the ratio of intercept formed on one transversal is equals to the ratio of intercept formed on other transversals. So look at in this figure, we will get AC upon CE equals to BD upon DF according to property of 3 parallels and their transversals. Now we will substitute here value. We will get 5.4 upon 9 equals to 7.5 upon DF. Therefore DF equals to 7.5 into 9 whole upon 5.4. Now we will simplify this. We will get DF equals to 12.5. Let's see the second question based on property of 3 parallels and their transversals. In this trapezium, you can see that side AB, side PQ and side DC are parallel. AP is 15, PD is 12, and QC is 14. It is asked to us find out BQ. So here we know that all three lines are parallel. It's a given. Now we will use your property of three parallel lines and their transversals. That you all know that what it is. Ratio of intercept formed on one transversal is equals to the ratio of intercept formed on other transversal. That is AP upon PD equals to BQ upon QC. Now we will substitute here value. We will get here 15 upon 12 equals to BQ upon 14. Therefore, BQ into 12 equals to 15 into 14. Therefore, BQ equals to 15 into 14 whole upon 12. Now we will simplify. We will get BQ equals to 17.5. So whenever you find three parallel lines, think about property of three parallel lines and their transversals. Now here we have the next questions based on property of three parallel lines and their transversals. It is given that in trapezium PQRS, AB parallel PS parallel QR, and if PA equals to 3 cm, AQ equals to 1.4 cm, BR equals to 2.1 cm, then find SB. Here we have options. Option A is 2 cm, option B is 2.5 cm, and option C is 4 cm, and option D is 4.5 cm. So you have to find out the correct option for this question. Alright. To know the correct option for this question, you need to apply property of three parallel lines and their transversal. That is, look at in this figure, that is PA upon AQ equals to SB upon BR. Okay, and after that you will substitute the value of known segment and you will simplify. You will get 4.5 centimeter. So here SB is 4.5 centimeter. Thank you.